first of all, before I talk about this, let me talk about a couple of the clues that people asked where I said, well, that's kind of a difficult question. And I think the most important question was somebody asked, do I work with creating energy in some ways? And people ask, do I work with coal? Do I work with nuclear? Do I work with solar? Do I work with hydro? And I definitely work in an area that in a way creates energy, but in a way it's very different because I work in an area where our object is to save energy. And when you save energy by making a building, for example, more energy efficient, that makes energy available for somebody else to use. So, in a way, saving energy is the same thing as creating energy for somebody else to use. And my job involves saving energy in buildings. And so I'll talk here a little bit about energy use in buildings. And I first want to get my pointer up here so you can see. Let's talk about this right-hand pie chart, and you can see this all right, Mr.
Yes.
Feller?
Yeah, we can see that
Okay.
fine.
So this is a pie chart of energy used in houses. And as you can see, and this is from 2009, it's a little old, but things have not changed very much since then. And you can see here that space heating and air conditioning, if you add these two, the blue pie and the red pie piece together, it's almost half of the energy used by a house. And then in addition, water heating is another 18%, and lights and TVs and computers and vacuum cleaners and everything else uses about 30%. So my work involves mainly heating and air conditioning. And I think another thing I'll mention before we go on is about 80% of the total energy used by a house actually comes from fossil fuels, which are fuels that were stored in the ground millions and millions of years ago when plants died and were buried and turned into coal, oil, and gas. And we take that energy, those energy sources out of the ground, and we burn them to heat our water, to heat our houses, to air condition our houses, to run generators that produce electricity that we use for lighting. And when we do that, that produces carbon dioxide that's emitted into the air, and that carbon dioxide is what is causing what we call global warming, where it's causing the Earth to slowly heat up and melt the glaciers, and I'm sure you know all about that. So this pie is the amount of energy that a house uses. Here's the amount of energy. This pie is the amount of energy that the entire United States uses, and you can see that houses are close to a fourth of the total. Commercial buildings use another third or a fifth or so. These two together are close to half, and these are both uses of energy that involve buildings. And over here we saw that about half of the energy use by houses is for heating and cooling, also for commercial buildings. A lot of that energy use is heating and cooling, and that's what I'm involved with. So I'll talk a little bit about what we do. I'll show you one of our products. This product, some of you have maybe seen if you've had an energy audit done at your house at home. This device, which is one of several devices that we make, and I help design this test equipment for, and this piece of equipment is called a blower door, and it's used for measuring how leaky a building is. It measures how big are all of the holes in the house if you could somehow add them all up together. So this device, called the blower door, consists of a aluminum frame that you can adjust the size to fit into a door opening, as this is one of the people that I work with every day, setting this frame up to seal, to fill the space where a door normally goes. And then we stretch this piece of red nylon over the frame of the blower door, and then put it in the door opening. And there's some little levers here that allow this to expand and seal very tightly the door opening. And then we install this device, which is a big fan that fits into a stretchy bungee here in the panel, and allows us to seal a fan into the doorway. The fan has a special sensor on it that measures how much air is going through the fan. And we turn the fan on, and we measure how much air is going through the fan, and we measure how much pressure. And I don't know if you guys know about pressure. You certainly know about when you blow air in a balloon, it creates pressure in the balloon. We're doing something similar. We're blowing air in the house, and we're creating a pressure in the house. And we measure what that pressure is, and we measure how much air we need to blow into the house to keep it at that pressure. And that tells us, that's a measure of how leaky the house is. How much time do we have? About another 5 minutes or so? Wayne, are you there?
Yes, Gary, we've got about another 8 minutes left.
Okay. We could certainly have people ask questions as I go on, or I'll just go through some slides and talk about what do we find when we go out and test houses. So let me go back.
By the way,
here.
Gary, what I'm doing is I'm opening up another open-ended poll. Another open-ended question place for the audience. So as you're talking, students can write another question as you're talking, and if another question comes in, I'll relay it to you.
Okay. So here's a diagram showing a typical normal house. And the arrows show some of the places where houses allow air to come in and to go out. And back when I started working on energy use in buildings, people mostly thought that the places that houses leak are the windows and the doors. And that's true that the windows and the doors do leak some. But typically, especially in newer houses, windows and doors have gotten better, and usually that's not the major place that houses leak. And even now, I think most people that even build houses don't understand the importance of some of the places where houses leak. And you notice all of the arrows going out of the house are places where air from the house can leak into the attic. And if you've ever been in your attic, you know that when you go up in your attic, you can see daylight in places like up here at the peak, or sometimes down here at the eaves, because the attic is open to ventilate heat and moisture out of the attic. So the attic is really supposed to be outside. There's insulation on the attic floor between the house and the attic to hold the heat in, but that insulation is just fiberglass or cellulose insulation it does not make the house airtight. So we have all of these holes like around, especially recessed ceiling lights usually are very, very leaky unless they're brand new special airtight ones. Often around the bathroom fan or a kitchen fan, there's often leaks. Uh, a source of leakage that hardly anybody realizes how important it is the the tops here, the tops of the walls that are between two rooms. These walls are hollow. When you go around and walk around a house, you don't think about the fact that the walls are actually hollow, and air can leak in the crack at the bottom of the wall. It can leak out the crack around the doors between rooms. Wherever there's an electrical outlet or a switch, there's some places where air can leak into the wall. Then the air can go up the wall and leak out the top because the top isn't sealed carefully. Now, in the last 10 years or so in Minnesota, most of the leaks that are shown in this picture are supposed to be sealed, but some builders aren't as good as others, and so some of these leaks aren't sealed very well. And if you have an older house that hasn't been had an energy auditor and somebody come out and seal the attic, most old houses have lots and lots of places like this where air can leak the attic, and then when the air leaks out of the top of the house, that causes other air to get sucked in the bottom of the house. And there are some leaks, especially where the first floor sits on top of the basement wall. There's often some pretty big leaks there, and wherever there's anything going through the wall, there'll be air coming in.
Gary, one of the students asked the question about your job title. Do you actually have a title?
Yeah, I am the president of a company called the Energy Conservatory, and we make this test equipment like that. That's one of our pieces of test equipment. We also make this gauge that measures very accurately the pressure difference between inside and outside and the air going through this blower door fan. We also make a similar device that's used for measuring how much the ducts in a house that carry the then cooled air around a house, we measure how much the ducts leak. Because sometimes, and I think I have showed this in this picture here, I'll go back here. So here's another diagram of a house where we have a small attic. This kind of a house is called a story-and-a-half house, where you have on the second floor of the house, you'll maybe have a sloped ceiling and a wall that's insulated, and there might be a little cubby hole where you can go out and get into the attic. Sometimes there's ducts up in this attic, and the ducts have leaks in them. And so whenever the furnace is running, air gets blown out into the attic, and it heats this attic space up, and that causes the snow to melt off the roof in this area. And then when the water runs down, it freezes when it hits the overhang over in this area, and then that can cause what's called an ice dam, and then water backs up and it leaks into the house, and it makes the ceiling, damages the ceiling, and causes all kinds of expensive damage to the house. So my job is not only involving saving energy that you have to use to heat all of this air that's leaking out, it also makes houses more durable, more comfortable, the indoor air quality better because you can control the indoor environment when you seal up a house. So my job isn't just to help make buildings more energy efficient, but also those other things. And I'll show one last slide. If when it, just after a snowfall, if you go out right after a snowfall, you'll notice that most of the roofs, the snow is all uniform in thickness. But after a couple of days, especially if it's just a little bit below freezing out, you'll find that some areas in the roof, the snow melts off before other areas. And this is often an indicator, like in this case, this is an indicator that there was one of those walls that was open at the top and warm air is leaking into the attic and hitting the underside of the roof and it melts the snow off. So you can learn a lot about where houses leak by looking at how the snow melts off the roof, but you can also find these things by using a blower door, and then so we create a slight negative, we say negative pressure or vacuum in the house, which causes outside air to be sucked in everywhere, and then we go around the house and feel where's the air coming in, or we might use smoke pencils or infrared cameras to see where the air leaks in the house from outside when we run the blower door.
Gary, thank you very much for this very interesting video conference this morning. One last question that a couple of students are asking is, what is it about your work that you enjoy the most?
Oh, I enjoy the science of figuring out how to measure important things that affect the energy use of houses and how to teach people how to use those devices to find heat loss in houses. And I enjoy teaching people about the basic science of how houses work and how we can make them more efficient so that we can make houses that are going to be more durable, more healthy, use less energy, and more sustainable. Ideally, when you build a house, you'd like to have it last 200 or 300 years, as many houses do in Europe, but most houses in the United States only last 50 or 100 years, and then because they're not built very well, they rot and they have problems, and a lot of that's just related to not very good construction quality. And so my job is to try to help improve that, try to get people to build more sustainable, more efficient, healthier houses.